Alvi Lepang, taking up Bachelor of Science in Electronics Technology, and today we will talk about graphs data structure. But first, let us define data structure. Data structure is collecting of data values, organizing and storing data in a computer. In such way, we can perform operations on the stored data. And now, let us discuss what graph is. A graph is a common data structure that consists of a finite set of nodes, or vertices, and a set of edges connecting them. A pair of x and y is referred to as an edge, which communicates that x vertex connects to the y vertex. Graphs are used to solve real-life problems that involve representation of the problem space as a network. Examples of networks include telephone networks, circuit networks, social networks like Facebook. For example, a single user in Facebook can be represented as a node or vertex, while their connection with others can be represented as an edge between nodes. Each node can be a structure that contains information like user's ID, name, gender, and etc. As we can see in this image, the nodes of the graph is represented as a vertex, thus 0 to 4 are vertices, and the edge represents a path between two vertices or a line between two vertices. And in this image, we can see the adjacency where two nodes or vertices are adjacent if they are connected to each other through an edge. In the following example, B is adjacent to A, and C is adjacent to B, and so on. And in here, we can see a path that represents a sequence of edges between the two vertices. In the following example, ABCD represents a path from A to D. And to continue, here are the basic operations of a graph. When you want to add or remove a vertex, you simply add a vertex to a graph, and when removing vertex, you must remove all the edges originating from the ending of the deleted vertex. Add or remove an edge. This operation adds or removes an edge between two vertices. When all the edges originating from and ending at a vertex are deleted, the vertex becomes an isolated vertex. Breadth first search, or BFS, is a traversal operation in the graph. This means that it traverses all the nodes at a single level before proceeding to the next level. The BFS algorithm starts at the top of the first node in the graph, and it traverses all the adjacent nodes to it. Once all adjacent nodes are traversed, the algorithm repeats the same procedure for child nodes. Depth first search, or DFS. It traverses the graph vertically. It starts with the root node or first node of the graph and traverses all the child nodes before moving to the adjacent nodes. And let's proceed to the uses of a graphs. Graphs can be used in navigation system, web pages link, data transmission, social networks, fluid dynamics, critical path analysis, 3D modeling, games, and simulations. And let's move to the summary of a graph. Graphs are awesome data structures that use every day through Google Search, Google Maps, GPS, and social media. They are used to represent elements that share connections. The elements in the graph are called nodes, and the connections between them are called edges. And that's all for today. Thank you for watching, and keep safe, everyone.